Hey, what's up everybody? I'd like to welcome you to another Juice tutorial. And for this tutorial, what we're going to do is we're going to start going into this process of building a simple delay. And the first part in this process is going to be building a circular buffer. Now, building a circular buffer in this tutorial, we're not actually going to be producing any sound. We're actually just going to build the circular buffer itself because it starts getting a little bit fiddly just trying to explain the ins and outs of copying from one buffer to another and what happens when you get to the end of one buffer. Okay, so it gets a little bit fiddly. So I'm going to break this down into a couple parts. So this particular method isn't something that I came up with, and if you look online, there are actually quite a few resources to actually look at how to build a circular buffer. This particular method is one that I've picked up from Daniel Walsh, who's a senior software engineer at Rolly, and he doesn't know that I've actually done this, but I've actually just looked at his delay plugin and I've pulled this out. So I hope he doesn't mind. I'm sure he's not going to mind. And Daniel Walsh is an amazing software engineer, and he's taught me so much. And so I'm going to share this with you. And it's just one part. It's just one little part of his plugin. So yeah, it'll be all good. And so building a circular buffer is something that you need to know how to do if you're going to make just about any effects plugin, really. And this is a process where you're taking the data that's coming in. So you have this audio that's coming in that's being represented by values that are in your buffer, right? They're floating point values that are in your buffer. And then this is a process where we're taking chunks of data, and what we're doing is we're copying it from one buffer to another buffer. Now in this buffer, we might do something that some sort of processing where we might want to look to values in the past, take that chunk of data and then put it out like in a delay, or we might want to run it through a distortion algorithm and then build like a distortion unit. So this is a process that you need to know how to do if you're going to build just about any sort of effect plugin. And I'm going to show you the first part of this process. Like I said, we're not doing actually any sort of audio output today. I'm just teaching you how to build the buffer itself. So the first thing that we need to do is, so as I showed you, we have this buffer is of an audio buffer float type. Okay. You can think of it kind of as a vector, sort of. And so what we need to do is we need to create another audio buffer. So I'm going to do that now. So we're going to call this audio buffer. This is going to be of type float. And I'm going to call this M delay buffer. So I put an M here. This is actually a little thing that I picked up from Daniel and also from another guy that I've been working on a project with named Matthew Garcia. Fantastic engineer. You should follow him on Twitter. He's just the man. He's taught me so much. And this M just means member variable. Okay, this is just something that we can put in front of our global member variables just to say so when we're looking in the code, it says, hey, this is a global member variable. Okay, as opposed to maybe P or an MP in front of it, which would mean member pointer or pointer. Okay, so now I've got this delay buffer, and what I'm going to do is I'm going to give it a size because it doesn't have a size yet, and I can use this method called set size, right? So I'm just going to go into prepare to play. I'm assuming by this point you know what prepare to play is, so I'm not going to go through that with you again. So we're just going to go M delay buffer, set size. And here I'm just going to, before I put these to variables, I'm just going to actually just set a couple variables here. So I'm going to do a const int. So You know that const, I hope you know that const means that it's a value that you can read from, but you can't actually change the value. Okay, so something like the sample rate or how many samples per block or how many input channels we have. Once we start actually playing audio, those aren't really values that we want to change. So what I'm going to do is I'm going to set the number of input channels to this variable. So I'm going to just call this number input channels equals get num input channels. Why is that? Why was that crossed out? Interesting. Okay, so what happened there? I think it's now get total number of input. Get total, yeah, there it is. Get total number of input channels. That's it. So sorry about that hitch there. And so now I can just put num input channels here. Now, the number of samples that we want to make it. So here's a situation where we have a buffer and we have audio that's coming into this buffer. We want to take that data, we want to copy it to another buffer, right? Now, we run into a situation where we might want to access data that's in the past. Okay, so if we wanted to make a delay and we wanted to take that chunk of data and we wanted to keep delaying it, then we need to be able to access that data, right? So if it's data from 1 second in the past, then we want to be able to access that data. We still need to be able to grab it to keep delaying it. So what we want here is I'm going to do another const int, and I'm going to go delay buffer size equals. So now if we think about this, right, if we have a sample rate of 44,100 values a second, and then we have our samples per block, which is going to be probably 512. If I want to access 2 seconds of that, that would be 88,000. So that would be 88,200 values times samples per samples per block squared, right? So if I wanted to access 1 second, we would have sample rate times samples per block, right? So that's how much audio is going to play in 1 second. Okay. Now let's say I want 2 seconds of that. Okay. So I'm just going to do 2 seconds of that, just like that. Okay. And that gives me 2 seconds of breathing room in my delay sample buffer. So here I can just set this to delay buffer size, and that's going to give me 2 seconds of audio that I can access in the past that I'm going to be able to do whatever I need to do. Okay. So that's the reason why this delay buffer is not the same size as our main buffer. And as you can see, that's going to cause us to need to do a little bit of math modulo kind of trickery in order to be able to wrap these values around. Okay. And you'll see what I mean in a second. So now we're going to get down here to the process block. Just going to erase this, but keep this for loop. So we're going to have this for loop where we're iterating through the channels, right? So we're going to have channel 0. It's going to do some processing. Then this is going to go to channel 1. Then we're going to do the same processing, right? So that's for our left and right channels. So first thing I'm going to do is I'm just going to create some variables to make this a little bit quicker for us to write. So if we can do const int buffer length equals buffer get num samples. Okay, so this is just so I can just have a little, so I can just write buffer length rather than buffer get num samples every time, because it looks a little bit messier every time you write buffer dot get num samples. So I'm going to do the same thing for my delay buffer. Equals delay buffer get num samples. Okay, so you can think of these as like kind of like vectors, I guess. Just how many values we have in a sample block, right? In a block of audio code, right? And those are going to be a collection of floating point numbers. Now we're going to, and what we need to do is we need to be able to read from our main buffer and read that block of data, and then take that block of data and place it into the delay buffer. So the delay buffer is just the same thing as our main buffer, but we're just taking values, we're just copying it from our main buffer to the delay buffer. Okay. But because these are two different lengths, then we need to do a couple different things just to make sure that everything kind of plays nice with each other and we're not running out of bounds on our buffer. Okay. Now what we're going to do is we're going to create read pointers for our buffer and our delay buffer. So what this means is that we're going to, so we're not actually writing to them, okay? We're not actually changing or placing anything into the buffer. We're just reading from one buffer and we're just going to place it into another buffer, okay? And we're just going to actually copy it to another buffer. And the way we're going to do this is we need to create read pointers. So we got const. Once again, these are things that we're just reading from. We're not actually trying to change them. That's why I'm putting them as const. Okay, so we got const float. Let's just say buffer data equals buffer get read pointer. And here I could put the channel number. And remember we're in this for loop here, so I could just put channel here. And then I can do the same thing for the delay buffer. Equals delay buffer get read pointer. Once again, this is stuff, this particular implementation is not something I made up. It's actually coming from my good buddy, Daniel Walsh, and it's coming from a delay that he's actually created. I'll go ahead and link you to it below in the description. And if you don't know Dan is the absolute man, and he's one of my favorite software developers. So big up to you, Dan. So now, what we're going to do is we need to come up with a little bit of math that's going to help us describe how we're going to work with these buffers when they come to the end of their length, right? Because there's going to be a point where we get to the end of our delay buffer and we want that to wrap around, right? So the first thing that we're going to do is we're going to be able, so the first thing that we're going to do is we want to be able to wrap this delay buffer around so that when we get, like, let's say we have our delay buffer is like 10 values and we get to 9 and 10 and we need to copy the next value from our main buffer into our delay buffer, then we need to go back to index 0 and copy that next value in index 0. Okay, and this is how we're going to do that. So we're going to create another variable. We're going to call this write position. And this is something that I've learned from Matthew Garcia, where I can just initialize that right here using these curly brackets, right? So you can use a member initialization list as well in your constructor if you want to, But this is something I quite like doing this right here, because this actually just lets me know. I can just look at my global variable and I can say that's the initialization right there, and I can just see that right then and there. Okay, so what we're going to do is first thing we're going to do is we're going to copy the data, right, from main buffer to delay buffer. And I'm going to show you how to do that. And then once we've copied those values, let's just say it's 512 values because that's a common buffer length, right? Then we're going to say mWrite position, which was initialized as 0. So if we've copied 512 values from the main buffer into our delay buffer, then we want to move the write position because we want to make sure that the next value that we actually get ready to copy into the delay buffer is value 513 and not value 0, right? So this is why I'm doing this. mWrite position plus equals buffer length. Okay, so this is me saying the first time that I've copied this data, 512 values, now I'm going to move this 512 value. I'm going to move the write position 512 values over on the delay buffer, so that the next value that I write is value 513, right? And then I'm going to say, now this is going to be modulo, okay, delay buffer length. Okay, now the reason that I'm doing this is to make sure that I wrap around when I actually get to the very end of my delay buffer, right? So let's say that my delay buffer is of length 10, right? And that my write position is at 11. Okay. Then what's going to happen is that you're going to do 11 modulo 10, right? Which means 11 divided by 10. And now we're just looking for the remainder is going to be 1, right? So because 11 divided by 10 equals 1 time, and it gives you 1 remainder. Okay. If you don't know what modulo is, I would highly advise that you check it out, because you're going to need it all the time in DSP. Okay. It just means that when we get to the end, we're just wrapping it around. Okay. We're just wrapping it around to 0. So when we get to 10 values, if delay buffer length was 10 values, once we get to 10, the next one would be 10. So when we get to index 10, then when we get to this point, to this line of code, it would say 10 divided by 10 equals 1. So because 10 goes into 10 one time, but the remainder is 0. So the next place it would write would be into index 0. Okay, I hope I made that clear to you. Okay, so modulo, very important. Okay, so now we need to go through this business of actually writing from the main buffer to the delay buffer. So we need to do a couple checks here. Okay, so first one is we need to check that the delay buffer length is greater than the buffer length plus the write position. Okay. And I'm going to show you this now. Okay, I'm just going to bring up my text edit here and just give you a really quick example. Okay, so let's say that we have a buffer that has 10 values, and that we've created a delay buffer that has 20 values. Right, and then our write position is 0. Okay, so now we're saying, okay, so we have delay buffer, which is 20, plus, so we need to check that that is greater than our buffer, which is 10, plus our right position, which is 0, right? But let's say we get to a point where we say, okay, now we're at a point where we're at buffer equal, the buffer is 10, right? That stays the same, that doesn't change, plus the right position is now 11, right? So we've copied 10 values in, and now we want to copy the next, value. So 10 plus 11 is 21, right? And we can see that 21 is greater than 20. So what are we going to do? So we need to make sure that, so now we're in a position where we have our right position is at 11. 11 values have been written into the delay buffer so far, which means we have 9 values left, right? So we got 9 values left, right? Now, how are we going to get these remaining 9 values into this delay buffer? So what we need to do is we need to go delay buffer, which is 20, right? That's the length of 20, minus the right position, right? And for our next iteration, we're going to be able to copy 9 values, okay? And that gives you, so we have the right position is 11 values, right? The next iteration, we've copied 9 values. That gives us 20, right? So now we've filled our delay buffer, and then for the next one, we need to go back to 0, okay? So that's why we're doing this here, to make sure that this wraps around and that we're able to write all of our main buffer values into our delay buffer and account for those differing lengths. So the way that we do that is we're going to say, let me think here, is we're going to say, so we're going to say M delay buffer. So we got our delay buffer. We're going to copy this from our main buffer. So we're going to take what's in our main buffer and we're just going to copy it to our delay buffer. Okay. For this first situation, it's fine because our delay buffer length is greater than our buffer length plus our right position. So we're fine in terms of length here. Okay. So to fill in these arguments, so copy from with ramp means that I'm copying from my main buffer to my delay buffer. And this lets me put what channel I want to copy from, what sample that I want to start with, and also lets me do a gain if I want to change the volume of those. Okay, we're not going to worry about that for now, the gain part. But channel, we can just, since we're in this for loop here, I can just put channel, right? Just like that. Okay, and that's going to automatically iterate through our channels. So our sample is going to be the right position. Okay, so we want to go, so if we started and we went 512 samples in, then that's going to move our right position there so that we're going to be able to copy the next chunk of data, not go back to the very beginning again. Okay, our source that we're copying from is going to be our buffer data. Okay, so we're just getting our data. We're just reading the data that's in our main buffer. Okay, the number of samples that we're going to do is buffer length. Okay, that's just how many samples that we have in our buffer. And here I'm just going to put 0.8 and 0.8. Don't worry about that for now. That's just the gain, right? So now what we need to do is we need to account for when the buffer length and plus the right position is greater than the buffer length. Okay, so as I said before, right? We need to create this equation here, delay buffer minus write position. Okay, so we need to do else, and I can do const int. And I'm doing an int here because we're accessing index values, right? So index values as in the value of index 5, index 7, a vector is not going to have an index of 7.5, right? So that's the reason I'm doing that. So I'm going to call this buffer remaining. And we're going to do the delay buffer length minus the write position. Okay. So just like I did here. So we have the length of the delay buffer minus the write position. Okay, and that'll tell us how many values that we need to copy in that next iteration. So like I said before, our write position is at 11, and then we have 9 values left in our delay buffer that we need to copy. Okay, so that's how we're doing that. We're saying delay buffer minus the write position shows us that we have 9 values that we can still copy to the delay buffer, and that's how we're doing that. Okay, so we got m delay buffer copy from with ramp. We got channel, and we got, once again, we're going from the write position, and then once again we're going from buffer data. We're copying from our main buffer, and then our number of samples is the buffer remaining. Okay, that's the number of values left that we need to take and copy back into our delay buffer. Then once again I could do this 0.8 and 0.8 because we're not going to worry about that from now. And then what we do. So now we've come to the end, right? We've come to the end, and now what we need to do is we need to set our delay buffer back to the beginning, to copy from the beginning of the next chunk of data, the next chunk of buffer data, right? So which means that we go m delay buffer copy from with ramp channel, and this is going to start with 0, right? So what we've done here, going back to our example, is we have 9 values left, right? So I had 11 values that I filled up, and now the next so then I've filled it up with 9. So now I've filled it up. I've filled my delay buffer up with 20 values, right? So my delay buffer is filled. So now I need to go back. I need to go back to the beginning of the delay buffer. I need to go back to 0 again, right? And I need to start overwriting what values were in my delay buffer. Okay, so once again, we're doing buffer data. Then we're doing the buffer data. Let me think about this. Buffer length minus buffer remaining. Okay, and then 0.8 and 0.8. Okay, so we got buffer length. So what we've done is, okay, so we've said, okay, so we have each time we've copied, each time in this example, we've copied 10 values, right? So we're going through 10 values, right? Each time that we're going through this iteration. So what I did was I copied 9 values, right? And now I still have 1 value remaining in my iteration that I still need to copy to the delay buffer from my main buffer. And that's what this next line of code is about, is saying, okay, so now I'm wrapping around. I'm going to I'm going to the beginning of my delay buffer again, but now I have to take the rest of the data that's remaining still. So in this short little example, I have one value that's still remaining, and I have to copy it to the 0 index of the delay buffer. Okay, so that's all I'm going to do for this time around. Okay, because I think that's quite a bit of information to digest, and this is something that we can later probably put in a function, a whole separate function, but I'm just going to leave it here for now because I feel like if I do any more, I'm going to mess up. Okay, so this is where I'm going to end things, and I hope you enjoyed this tutorial, and be sure to join our Patreon, the Patreon support group if you want to donate to the channel. If you don't, it's cool. You can just still do this for free. And also be sure to check us out on Discord. We have a lot of great, talented developers from all over the world. Some people from Rolly and some people from some other really great companies around the world that are in the group and contributing and having fantastic discussions on different things. So I hope you can join, and I hope you enjoy this tutorial, and I will see you next time.